Hello everyone, hope you are doing well. Welcome to this educational video. I'm Reza, founder of the optimizationct.com. In this video, we will learn how to solve the linear programming model using the graphical method, and then we solve the same model with the GAMS software, the well-known commercial web software for optimization problem. And finally, we solved the same model using the online solver provided by website www.optimizationct.com. So let's get started. In this video, we'll cover the following topics: presenting the model, solving the model graphically, solving the model using the GAMS software, and solving the model online with the solver on website www.optimizationct.com. The given linear programming model is as follows. We have the objective function in the form of the maximization. Z is equal to 6x1 plus 8x2, subject to two functional constraints. 13x1 plus 20x2 is less than 300, and 5x1 plus 10x2 is less than 110. We have also non-negative constraint for x1 and x2. These models have two variables and two constraints. These two constraints is functional constraints, and this is the non-negative constraint. Okay, to solve the model graphically, we first plot the feasible region. We start with the first constraint. The first constraint, it means we need this space. Okay, the first constraint, 3x1, 13x1 plus 20x2 is less than 300, pass through point 10, 0, and 4, 9. So we plot this line. Okay, here 4. First, I should write here this is x1 and the vertical axis is x2. 4 and 9. Okay. First constraint between 10, 0 here and 4, 9. This is first constraint. Since the origin, it means 0 and 0, satisfy the constraint 13x1 plus 20x2 is less than 300. Here, 0 is less than 300. The feasible region is below this line. So this is the feasible region for first constraint. The second constraint, 5x1 plus 10x2 is less than 110, pass through 2 points. 10, 6, and 0, 11. So we plot 10, 6, and 0, 11. 10, 6, and 0, 11. Okay, this is the second constraint. Second constraint. Since the origin, it means 0 and 0, satisfied this constraint, 0 is less than 110, so the feasible region lies below this constraint. Okay, so remove here line. That's it. Okay, Considering a non-negative constraint for x1 and x2, these two constraints, the feasible region lie in the first quadrant. So as a result, this is the feasible region for this model. Okay, to find the optimal solution, we plot the objective function for z is equal to 0 and z is equal to 24. If z is equal to 0, we have 2 points, 0 and 0 and minus 2, 1.5. If z is equal to 24, we have 4, 0 and 0, 3. Now we plot these two lines. Okay, 0 and 0 is the origin, and minus 2, something like this. Okay, and 1.5. This is the other colors. No, okay. This is z is equal to 0, and for z is equal to 24 is 4, 0 and 3, something like here. I can see it. It's polar. This is for z is equal to 24. As objective function, z is equal to 0. As objective function increase, the line shift upward. And the highest achievable point in the feasible region is equal to here. This point. What is this point? This point is 4, 9, making it the optimal solution is equal to z is 96. So this is the optimal solution for this model. Now let's solve the model using the GAMS software. GAMS software is a commercial software for solving the optimization model in the format of the LP, non-LP, IP, and so forth. First, we define index I. I is 1 and 2. Next, we declare the variable and ensure they are non-negative. So xi, it means we have x1 and x2. We know that we have two variables. Also, x1 and x2 is non-negative, so we write positive variable x for x1 and x2. But objective function obj fu is not non-negative, is the free in sign. So we just say variable obj fu. We define the objective function and the constraint in the equation. This is obj for objective function and const1 and const2 for constraint 1 and constraint 2. Constraints are written, objective function is written in this format, obj fu is equal to, it means this is equal. So obj fu equal to 6x1 plus 8x2. Constraint 1, 13x1 plus 20x2 is less than, equal L equal, it means less than 300. And for constraint 2, 5x1 plus 10x2 is less than 100. We solve the model using the NLP solver. LP is a special case of the NLP, so we can use these solver and in the format of the maximization, because we have max in objective function. To maximize the objfu, this is objective function. To display the optimal solution, we use this format, display x.l. It means the level of the x1 and x2. This is objective function for x1 and x2. So let's see what happened in the GAMS. We have this code in the format of Notepad, and we refer to the GAMS software. By clicking the red arrow, we get the result. In the display section, you can see that the x1 is equal to 4 and x2 is equal to 9, and objective function is equal to 96. So we get result identical to the graphical solution. Now let's solve the model using the online solver on www.optimizationcity.com. To do this, we navigate to website www.optimizationcity.com or solver and prime simplex methods. So here we have some data we need to enter. We enter the number of variable as n, number of constraint as m, the precision of the optimal solution, and A is a matrix of the coefficient or coefficient matrix. So what is this data? This is the model. We have two constraints. We need to rewrite here minus z plus 6x1 plus 8x2 plus 0x3 plus 0x4. x3 and x4 is auxiliary variable for constraint 1 and constraint 2. Also for constraint 1, 3x1 plus 30x1 plus 20x2 plus 1x3 plus 0x4 is equal to 300. This is equal to 0. For constraint 2, 5x1 plus 10x2 plus 0x3 plus x4 is equal to 110. So what is the matrix of coefficient? Here I write in the other color. Okay, A is equal to, the first element is the right hand side. Right hand side of the objective function is equal to 0. Right hand side of the first constraint is 300. Right hand side of the second constraint is 110. This is the right hand side. Coefficient of the x1 is 6 in objective function, 13 in first constraint, and 5 in second constraint. x2, 8 in objective function, 20 in first constraint, and 10 in second constraint. x3 is 0 in objective function, 1 in first constraint, 0 in second constraint. x4, 0 in objective function, 0 in first constraint, and 1 in second constraint. So this is all. For A, we enter in the objective function. We have here, n is the number of variables. We have 4 variables and 2 constraints. The precision is 0.001, and this is A. Okay, and we press run, and the solver provide the optimal solution which match the previous method, GAMS and graphical. One advantage of the online solver here, x1 is 4, x2 is 9, and objective function is 96. One advantage of the online solver is that it requires no software installation, unlike the GAMS. Thank you so much for watching. If you have any question, please feel free to contact us via email or contact form in website www.optimizationct.com. Please do not forget to subscribe our YouTube channel to see the last updated video. Goodbye.